Hello students, welcome to E-Pathashala. I am Dr. U. Ratna, Assistant Professor, Department of Textiles and Clothing, Avinashlingam Institute for Home Science and Higher Education for Women, Coimbatore, Tamil Nadu. Today we are going to see about the conventional spinning and other spinning methods in this module. And the process by which fibers are converted into yarn is known as spinning. The fibers during spinning are gently pulled out, drawn and twisted. This process helps to hold the fibers together, thereby increasing the strength of yarn. Spinning also helps us to make the yarn smoother and finer and to improve its strength. Spinning is carried out mainly for cotton, wool and their blends with other fibers like polyester. The natural fibers contain dirt and other impurities which need to be removed. For this, the fiber has to pass through different stages during spinning. The objectives of this module is to understand the concept of spinning, to gain knowledge about different spinning methods, to understand the functioning of different spinning machines. To carry out the various processes in spinning, a wide range of machines and methods are used. Different processes are as follows. First is opening. It loosens, opens and fluffs the fibers. Picking. This process also loosens, cleans and forms the fibers into lap. Next is carding. In this process, fibers are strengthened and forms the sliver. In combing, fibers are straightened and short fibers are removed. Drawing. It parallels, blends and reduces the size of strand. In roving, reduces the size further. Last is spinning. The twist is given and the final yarn is wound. Let us see the spinning process in detail. The first step is opening and picking. The masses of fibers from these numerous bales will be fed into a machine called a blending feeder. As these masses of fibers are loosened and thoroughly mixed, some remaining heavy impurities such as dirt, remnants of seeds, leaves or stems are removed by a line of machine known respectively as pickers, breakers, intermediates and finishers. Each in succession makes more refined, clearer raw fibers. From these machines, the fibers emerges as lap. Carding. The lap is unrolled and drawn onto a revolving cylinder covered with fine hooks or wide bristles. These wide bristles pull the fibers in one direction, separate those bristles which are individually tangled together and form them into a thin film. This process is known as carding. The thin film is drawn into a funnel shaped opening which molds it into a rope like strand approximately an inch in diameter, which is called as sliver. Next stage is combing. The comber is a refining device by which paralleling and straightening of the individual fibers is carried out to a more exact degree. The longer fibers are again formed into a sliver known as comb sliver. Drawing. In drawing operation, further blending is done by working together several slivers and drawing them out in the drawing frame without twisting but reducing the several slivers to a single one. Next is roving. The combined or condensed combed sliver is taken to a series of machines called roving frames. Last process is spinning. Spinning is a continuation of the roving, and onto the spinning frame many spools containing the roving pass through the ring spinning mechanism, which further draws and gives twist to a yarn of the required size and winds it on bobbins. Spinning includes all the process required to prepare and clean the fibers from the opening of the bale to the twisting of the yarn and its preparation for fabric construction. This process is called the conventional ring spinning method. Now let us see the yarn manufacturing system, which is the other spinning methods. First is the open-end spinning method. Open-end spinning is also referred to as OE spinning or break spinning. The technique has reached wide acceptance as a satisfactory process for spinning coarser yarns of counts up to 40. The open-end spinning process begins with the carded sliver and is fed on the succession of rollers, each advanced set of which revolves at a progressively faster speed, which completely opens up the sliver, and fibers can be fed virtually individually into the spinning operation. As the fibers are thus separated, they are transported forward by an air stream and are collected as a thin layer in a groove on the inner surface of a funnel shaped rotor, which rotates at a very high speed. The centrifugal force of the rotor builds up a multi-layer of fibers which is collected and is twisted by rotation of rotor and withdrawn continuously and formed in yarn. The primary difference between the conventional ring spinning and the open-end spinning is that in open-end spinning, the spools does not need to rotate in order to twist the yarn. Large spools can be wound, thereby providing very long knot-free yarn. Open-end spinning can produce yarn spun at a rate of 3 to 5 times that of conventional ring spinning. On the other hand, open-end spinning has its limitation. It is difficult to spin yarns of 100% man-made staple which gets deposited in the rotor and causes clogging. The yarn counts are generally lower than 40, which limits their use to a heavier, coarser fabric such as denims, towels, some poplins and interlining. Open-end yarns are spun with 20% more twist and they are 15 to 20% weaker due to their coarseness. Next is the friction spinning. Dr. Ernest Ferrer got a patent for friction spinning process which was commercialized under trademark DREF. This system was modified and identified as DREF, which is a variation of open spinning process. Friction spinning is an open-end spinning technique. Instead of using rotor, 2 friction rollers are used to collect the opened up fibers and twist them into a yarn in the same direction because the friction between the fiber strand and the 2 drum surfaces. Twist is inserted into the fiber strand. The yarn is withdrawn in the direction parallel to the friction drum axis and delivered to a package forming unit. There are certain advantages to the DREF system. The fiber preparation costs are lower because direct feed of cast slivers to the spinning zone is done. The high speed elements required for ring and rotor spinning are eliminated. Yarn breakage is avoided because there is no tension in the spinning area. The process allows the use of a wide variety and quality of fibers that can be used independently or blended into slivers. Friction spinning have a higher productivity than both rotor and air jet spinning. Novelty specialty yarns such as bosal and nub can be produced. Friction spinning is however restricted to coarse count range. Next is the air jet spinning. It is a variation of spinning yarn with an aid of an air stream. Air jet spinning technology was first introduced by DuPont in 1963 but has only been made commercially successful since 1980. It is a pneumatic process that produces yarn directly from high quality drawing sliver of wool, man-made staple or man-made and cotton staple blends. The air jet spinning technique drafts the sliver to a predetermined size and passes it through rollers over a friction plate into a cylindrical pneumatic twisting chamber. As a compressed air is released from the jet set in the walls of the chamber at a predetermined angles to the central axis of the tube, the fibers are whirled around each other. Special rings and specific grooves within the tube are used to loosen the fibers from the sides and to control the twist and strength parameters of the forming yarn. As the fibers are whirled through the first chamber, they are given either an S or Z twist. With the aid of air succession, the strand is passed into a second chamber where it is first stabilized and then given an equal amount of twist in the opposite direction. The strand is again stabilized to prevent back twist as delivery rolls draw on the yarn which is wound onto the take-up package. The air jet spinning produces a yarn of uniform diameter. Yarn can be produced in counts equal to or somewhat finer than those made by open-end spinning. The tensile strength of air jet spun yarn have been reported to be less than that of the ring spun yarn. It may be greater than that of open-end yarn. Coming to the vortex spinning method, vortex spinning technology is a modification form of air jet spinning and has a high productivity rate. In the vortex system, drafted fibers are introduced into a spindle orifice by an air vortex. While entering and passing through the orifice, fibers are twisted by swirling around and it can deliver yarn up to 400 meters per minute. Vortex spinning, which adopts high-speed airflow to insert twist into the yarn, is one of the most promising technological innovation in the textile industry. In vortex spinning, the dynamic behavior of the fiber inside the nozzle, which involves fiber airflow interaction and fiber wall contact, plays an important role in the twist insertion process. The moving parts in the machine are eliminated in this technique, which in turn provides a considerable cost saving. The yarn produced are weak and irregular. Next is the zero spinning. Zero spinning is a process to produce doubled yarn directly in spinning machine. Instead of one roving, two roving are passed in the drafting zone and they are twisted by the same spindle. Traditionally, two-fold yarns have been used for weaving because they are stronger and the twisting operation binds the surface fibers into the yarn structure so that it is smoother and more resistant to abrasion during weaving. The zero spun process adapted some of the self-test discoveries to the ring spinning technology of the worsted system and combined spinning and doubling in one operation. In zero spinning process, two rovings are led in parallel through the drafting system, separated by two specially developed condensers and drafted separately. The twist is introduced as for a normal single yarn by means of ring and traveler. The roving strands, which are drafted parallel, are combined after passing the front rollers at the exit from the drafting system, with some twist being produced in the individual strands right up to the nip point. Once past the front rollers of the drafting system, the two strands are combined, producing a two-fold like yarn. The yarn has unidirectional twist like a single yarn, but the fibers are bound sufficiently for the yarn to survive in the weaving process. A mechanical yarn break detector located below the drafting system continuously controls the yarn path of both single yarns throughout the spinning process. The main advantage of zero spun process is a reduction in spinning cost for pure fine wool weaving yarn, and it reduces cost by combining spinning and two-folding, allowing a two-fold like yarn to be produced in one step. Next is the electrostatic spinning. In order to increase yarn strength and improve spinning efficiency, researchers try to develop a system that would improve the uniformity, strength and appearance of cotton yarn. They began to exploring the possibility of removing the short fibers from the longer ones by electrostatic process. The principle is that widely differing material can be separated from each other electrostatically. The idea of separating different sizes of the same material, and more particularly cotton, was a novel approach. Under controlled conditions of humidity, it is possible to separate short fibers from long ones in electrostatic field. A mechanism was developed to remove the short fibers from long fibers as they pass through the electrostatic field and transport the desired long fibers by an air current. Thus, from the carded stage, the fibers are drawn out of the drafted by rollers and are fed over rotating cylindrical electrodes of high field intensity, which direct the long fibers to either an air current or an electrostatic field for transport to the combed sliver stage. The short fibers, which move more slowly and are carried out by rotating electrodes of low field intensity. The modification of this electrostatics device has shown that it can replace all textile processing equipment from opening through spinning. It can produce clean, net-free stand with excellent fiber orientation. Next is the twistless spinning process. This is the technique of making yarns of staple fibers without the need of twisting them around each other to achieve cohesiveness and strength are being developed. The methods are basically designed to place the fibers parallel to each other and have them adhere together with bonding agent, which is removed after the yarns are constructed into fabrics. One such process is the Twistless spinning. The Twistless spinning process forms yarn by temporarily binding the fibers together with an adhesive and subsequently removing the adhesive after the yarn has been made into fabric. A carded sliver of cotton, rayon, polyester or acrylic staple is blended on drawing frame with a sliver of water. PVA binder fibers. The blended sliver is then drafted 5 to 10 fold in a dry condition, wetted to activate the binder, wet drafted given a tangential water injection which causes the vortex that imparts a false twist, drafted 6 to 40 fold in its wet condition, and again passed through the false twister while steam or hot water is applied. The wet untwisted yarn is dried on the rotating heated drum and wound on a cheese at a rate of about 400 meters per minute. The resultant yarn is ribbon shaped and consists of parallel fibers held together by water soluble binding agent. After the twill yarn is woven or knitted into a fabric, the binder is removed by washing. Since the fibers can move slightly in the fabric's appearance may be affected in the finishing process and have a different appearance from that of comparable fabrics made of other yarns. Fabrics made of this twistless yarn have an attractive luster because the fibers in the yarn are relatively parallel to each other, thereby providing a flat, smooth surface. Dyes are more accessible to the fibers and deeper shades can be achieved. Fabrics of twistless yarn have been found to shrink less than those of conventional yarn. The strength of fabrics made of twill yarn depend upon the inherent strength of the particular fiber used in the yarn, and the strength of the yarn may be combined in the warp structure of a woven cloth. Coming to the filament yarns, the filament yarns are produced by different methods and then can be formed directly into a yarn without the use of technique to connect fibers together to form the required length. They are produced by two methods, that is the melt spinning and solvent spinning. Melt spinning uses heat to melt the fiber polymer to a viscosity suitable for extrusion through a spinneret. The solvent spinning uses large amount of organic solvent to dissolve the fiber polymer into a fluid polymer suitable for extrusion through spinneret. Solvent spinning is again divided into dry spinning and wet spinning. The spinning process used for a particular polymer is determined by the polymer's melting point, melting stability, and solubility in organic or inorganic solvents. Next is the melt spinning process. It uses heat to melt the polymer to a viscosity suitable for extrusion. Polymer chips are melted in an electrically heated screw extruder. Alternatively, the molten polymer is processed in an inert gas atmosphere, usually nitrogen, and it is melted precisely machined gear pump to a filter assembly consisting of a series of metal gauges interspersed in layers of graded sand. The molten polymer is extruded at a high pressure and constant rate through a spinneret into a relatively cooler air stream that solidifies the filament. Lubricants and finishing oils are applied to the fibers in a spin cell. Once formed, the filament yarn either is immediately wound onto bobbin or it is further treated for certain desired characteristics or end use. These lubricants and oil vaporize, condense, and then coalesce as aerosols primarily from the spinning operation. Next is the solvent spinning. First is the dry solvent spinning. This process begins by dissolving the polymer in organic solvent. This solvent is blended with additives and it is filtered to produce a viscose polymer solution referred to as dope for spinning. The polymer solution is then extruded through a spinneret as filament into a zone of heated gas or vapor. The solvent evaporates into the gas stream and leaves solidified filaments, which are further treated using one or more of the process. This type of spinning is used for easily dissolved polymers such as cellulose acetate, acrylic, and mod acrylic. Unrecovered solvent constitutes the major substance. The large amounts of unrecovered solvent are emitted from the fiber spinning step and drying the fiber. Other emission sources include the dope preparation, that is the dissolving the polymer, blending the spinning solution and filtering the dope. Next is the fiber processing, which helps in drawing, washing and crimping and solvent recovery. Next step is the wet solvent spinning. Wet spinning also uses solvent to dissolve the polymer to prepare the spinning dope. The process begins by dissolving polymer chip in a suitable organic solvent such as DMF, DMA or acetone as in dry spinning, or in weak inorganic acid such as zinc chloride or aqueous sodium thiocyanate. In wet spinning, the spinning solution is extruded through spinneret into a precipitation bath that contains a coagulant such as aqueous dimethylacetamide or water. Precipitation or coagulation occurs by diffusion of the solvent out of the thread and by diffusion of the coagulant into the thread. Wet spinning process that use solutions of acids or salts to dissolve the polymer chip emit no solvent only unreacted monomer and are therefore relatively clean from air pollution standpoint. Okay, now let us summarize the module which is on conventional spinning and other spinning methods. So, yarn can be made up to a stable fibers by several techniques. The method used depends upon the fibers to be used and the desired properties of the yarn to be produced. Conventional ring spinning is the oldest and the most widely used technique. Open-end spinning is another major method, and electrostatic spinning and twistless spinning process are the recent development in spinning. The filament yarns are produced by melt spinning and solvent spinning, and from this we can learn the other spinning methods. So, hope you have understood the different spinning methods in detail. Thank you.